Okay, now we're going to talk about graphs a bit. In this section, it talks about new functions from old functions. This is a quick review of composite function, the sum of functions, difference, quotient, all of these different things, and associated with some domain. So it's a review of graphing and shifting up and down, left and right. In this case, this is the graph of f of x. What do you think the graph of f of x minus 2 look like? Well, that's going to shift this graph, or this graph, 2 units down. So this point will shift 2 units down. This point will shift 2 units down. There's a line connecting those. You mimic that. This is shifted 2 units down, and this is shifted 2 units down. So the way you do graphs, you look for the main characteristics, and you just shift those. You don't have to shift every point. You could write those as points and add a negative 2 to all the y's, or subtract 2 from all the y's. This, if you remember, whatever is affecting x, you do the opposite. This is going to shift the graph 2 units to the right. So you take, again, the main characteristic points, shift 2 units to the right, 2 units to the right, 2 units to the right, and 2 units to the right. Connect those with straight edges, and there's the graph. So with reference to where it was, now it's 2 units to the right. This is multiplying the y values by 2. So you could do those point by point. You could say this is the point 2, 1, multiply the y by 2, 2, 2. Or you could stretch it by a factor of 2. 0 doesn't move. Stretches up to 2. And this is negative 3, negative 1. So it's going to be negative 3 if you multiply the y by 2, negative 2. And you'll notice the stretch along the y. Remember, whatever is affecting y, you pretty much do what it says. Whatever is affecting x, you do the opposite. In this case, f of 2x, this is going to multiply the y by a half, by the x's by a half. This is going to shrink the x's by a factor of 2. So if I take this point, 1, 2, 3, it's going to be, the y is not going to be affected, the x is going to be half of it. This is negative 1, it's going to be at a half. 0 doesn't get affected by anything. And this is going to be halfway through. So you could glance at it and figure out that what happened, this graph just shrank in half along the x-axis. So this pretty much affects the domain. And multiplying the y by a negative, that's important. It reflects the graph with respect to the x-axis. So there's the x-axis. That becomes a mirror image. Again, these points. So this point becomes right here. This point stays the same. This point becomes right here. And this point. And if you connect those with a straight edge, you'll notice the graph looks identical image through the x-axis. And there it is. Of course, you could list the points and multiply all the y's by a negative 1. A graph of a parabola, we know that looks like this. That 2 shifts the graph 2 units to the left. And a rough sketch will do. 1 over x is a graph that looks like this. That shifts the graph 2 units to the right. So instead of this line being there, to be 2 units to the right. And this will shift it 1 unit up, so that doesn't affect the vertical asymptote. However, the horizontal asymptote, if you shift it left or right, it doesn't get affected, but you're going to move it up 1 unit. And this graph just copies down this way. And if you notice, if you put 0, you get a half. And the graph looks like this. A rough sketch. The radical x is a graph that looks like this. The negative, multiplying the y by a negative, reflect the graph with respect to the x-axis. Now it looks like this. And the 1 will shift that 1 unit to the left. So it's important to see those graphs. If you're stuck on a problem, the graph will give it away. And if I get to this problem, well, a sine wave shifted up 1 unit, so I'm going to go up 1 unit. The amplitude is 1, so a unit above 1 and a unit below 1, that makes it y equal, a unit above 1, that's y equal 2, and a unit below 1, that makes it y equal 0. A sine wave starts at the origin, goes up to the amplitude, and back to the starting point. Now comes the labeling. The period is 2 pi divided by 2 pi, so that makes it a 1. This is 1/4 of the period, so that's 1/4, 2/4, 3/4, and 4/4. So that's pretty much it. This, however, is a bit tougher. 1, the amplitude is 1/2, and 2, the period is pi divided by 1, which is pi, but we have a phase shift. X equal negative pi over 4. So if I was to go ahead and go to my shift first, let's say pi over 4 is right there. This is my new origin. Now I know a graph of a tangent takes half of the period to the right and half to the left. Well, the period is pi. If I take half of the period, which is pi over 2, and I add the shift is negative pi over 4. That would be over 4, 2 pi minus pi, that would be negative pi, pi over 2 minus pi over 4 is pi over 4. Okay, so 1. So I know that the asymptote is at pi over 4. And I notice I went 2 to the right, so 2 to the left will give me, these graphs are symmetric. If I move from negative pi over 4 to pi over 4, that is 2 pi over 4. The left will be negative 3 pi over 4. And once I get one of those, I'm pretty much done. And there it is. I can sketch another period if I really want it. That's sufficient. And we're not done with the section, but this is where I'm going to stop for now. You should get this out of the way as a first lecture.